All right, in this particular example and the next two in this video, we're going to look at how we would find how much money you accrue on interest by investing your money and given the interest rate, and how many times a year the interest rate will uh, add to your initial value or your principal. So the formula we're going to need to know for that is you have the amount after so much time is equal to the principal P that you deposit, and then we're going to multiply that by a quantity, 1 plus R, which is the rate. And notice 5%, remember, that's a rate of 0.05. So you're going to have to keep that in mind when using this R over N. And that's the number of times that the interest is added per year. So in this example, Mrs. Salisman is investing $2,000, so 2,000 is our principal, and the account takes on a 5% interest rate, which is our rate, and she's going to leave it in there for 18 years, which we'll get to in a second, and the interest is compounded quarterly, meaning 4 times a year. So in this case, our N is going to be equal to 4. We're going to look at two other examples where it's not equal to 4. So we're also going to take that same n times the time. That's going to be the exponent to which we take this whole base 2. So let's go ahead and just plug in our values here. We know that the amount is what we're trying to find. Sometimes you'll be given the amount and you might want to have to go backwards to figure out the original principal. But in this case, the principal, which is the amount she deposited, is 2,000 times 1 plus my rate is 0.05 over 4 because it's compounded quarterly. And then we take 4 times 18, which is the number of years that the interest is in the bank, or the money is in the bank. So for this, I would just recommend using a calculator to make your work easier for you. So let's go ahead and get rid of this. Um, so if we put in 2,000 times 1 plus 0.05 over 4, all taken to the, and we'll want to put this in parentheses, this 4 times 18, or else it'll take that to the 4th power and multiply it by 18. So what we get out is $4,891 and about 84 cents. So that's how much money, not that she would gain, but how much money she would have actually in the bank account after 18 years. All right, so very similar idea in this one. The only difference is now that she's putting that money in, it's going to be compounded monthly. So again, A is what we're trying to find. The principal is still 2,000. The time is still 18 years, and the rate is still 0.05. So the only thing that changes is n, since it's compounded monthly, that's 12 times in a year. So rather than quarterly, she's going to get that interest tacked on a lot more, so she should accrue a lot more money. So again, our formula, A equals P times 1 plus R over N, the NT power. Put all of our values in, we get 2,000 times 1 plus 0.05 over 12 to the 12 times 18 power. And let's throw that all into our calculator. We get 2,000 times 1 plus 0.05 over 12, all to the 12 times 18 power. and that's going to give us $4,910.02. So 4910.02 is going to be my answer for that one. And we're just going to look at one more together. Now for this one, the amount is going to be compounded daily, so 365 times in a year. So again, we're just going to take that equation, A equals P times 1 plus R over N to the NT. Again, our P is 2,000 times 1 plus 0.05 over 365 this time, times 365 times 18. And that's going to give us, just to save us some time, you can try this in your calculator yourself, but it should get you $4,918.90. So let's go ahead and look at a couple examples for you to try on your own. And I said a couple examples, but really I just have one here. And this time it's Mr. Bourne investing $5,000 into a savings account at his bank. Go ahead and see if you can use that formula to figure out how much he would acquire after 11 years if that interest is compounded monthly.